All right, and these next two examples are they're a little variation of just the straightforward derivatives. But we're still just going to apply the product rule and the quotient rule. All right. So, but in this case, we just have generic functions f of x and g of x. But that's okay. We can do this. So, h of x is defined to be the product of f of x and g of x. All right. So if we want h prime of x, right? That's just it's just the quotient, or sorry, the product rule, right? So it's going to be f prime of x times g of x plus f of x times g prime of x. And then we just need to substitute in the value 2, right? Because we want h prime of 2. So that's just going to be, I'm just going to substitute 2 for x. So f prime of 2 times g of 2 plus f of 2, g prime of 2. All right. So now we can just use the values that were given up here. We have the values given here, I guess all the way back to here. So if we just find, we can see that f prime of 2 is 5, right? So I'll just write 5. G of 2 is 3. F of 2 is 1. And g prime of 2 is 6. Okay, so that is just arithmetic. So 15 plus 6 is 21. So the answer is 21. All right, let's look at this next one. This one is a quotient of two functions. So we're just going to apply the quotient rule. So now I have to calculate k prime of 2, but I'm just going to go straight to. So I need k prime, right? So it's going to be low, right? But I'm going to evaluate it at 2. And then d high, so f prime, evaluated at 2, minus high, so f of 2, d low, g prime of 2, all over low squared. That's g of 2 squared. All right, so now we just need to plug in values. So g of 2 is 3, right? So 3 times f prime of 2, which is 5, minus f of 2. F of 2 is 1, and g prime of 2 is 6. And then all over g of 2 squared, right? So that's 3 squared, which is 9. All right, let's do the arithmetic. 15 minus 6 is 9 over 9, gives us 1. So the answer is 1. All right, I'll meet you in the next video to go through example 4.